Hello friends, welcome to GSR ChemTube channel. Here we are going to discuss about atomic structure chapter. In this about electromagnetic radiations we are going to see. An electromagnetic radiation is a form of energy that is produced by the movement or oscillation of electrically charged particles which are traveling through either matter or vacuum. Here we can see different kinds of electromagnetic radiations are shown here. Actually, these electromagnetic radiations do not need any medium for their propagation. That means, as we told, they can travel even through vacuum also. Visible light, ultraviolet radiation, infrared radiation, X-rays, gamma rays, these all come under electromagnetic radiations. Characteristics of these electromagnetic radiations. Electromagnetic radiation is released as photons, which are bundles of light energy that travel at the speed of light. Electromagnetic radiation can travel through empty space too, that means through vacuum also. Most other types of waves must travel through some sort of medium or substance. For example, sound waves need certain medium like solid, liquid or gas to pass through and in order to be heard. An electromagnetic radiation is always characterized by certain properties. Let us see those here. One of them is wavelength. The distance between the two nearest crests or nearest troughs of a wave is called its wavelength. Here we can see the picture of a wave. Here this is called crest and it is called trough. The distance between the two nearest crests or nearest troughs is called its wavelength. To say from here to here, a complete wave represents its wavelength. This we can say as a wavelength. And it is denoted with the symbol lambda. It is measured in terms of, as it is a distance, it is measured in centimeters, meters, angstroms, micrometers, nanometers, etc. The most general used unit is angstrom. As we know, 1 angstrom is equal to 10 to the power of minus 8 centimeters or 10 to the power of minus 10 meters. Next one, frequency. It is defined as the number of waves which pass through a point in 1 second. It is denoted by symbol nu and it is measured in terms of cycles per second or oscillations per second or hertz. Frequency is inversely proportional to wavelength. That means mathematically we can write like this: nu is inversely proportional to lambda, or nu is directly proportional to 1 by lambda. So to remove the proportionality, it is taken a constant which is equal to velocity of light. Thus a wave of higher frequency has a shorter wavelength, while a wave of lower frequency has a longer wavelength. Both are inversely proportional. Longer wavelength waves such as radio waves carry low energy. This is why we can listen to the radio without any harmful consequences, whereas the shorter wavelength waves such as X-rays carry higher energy that can be hazardous to our health. That is why aprons are worn to protect our bodies from harmful radiations when we undergo X-rays. That means the waves with a longer wavelength have lower frequency as well as lower energy, whereas the waves with a shorter wavelength are having higher frequency and higher energy too. Frequency and wavelengths of different electromagnetic radiations are shown in this picture. We can see here, as we told, here these radio waves, microwaves have longer wavelength and hence they have lower frequency as well as lower energy. Whereas if you observe at the right side, some radiations like gamma rays and X-rays, they have very low wavelengths which are having higher frequency as well as higher energies. Most dangerous radiations are these. Next one, wave number. This is the reciprocal of wavelength. That means the number of wavelengths per unit length or per centimeter. It is denoted with the symbol nu bar. It is expressed in terms of centimeter inverse or meter inverse. Mathematically we can show nu bar is equal to 1 by lambda. That means the reciprocal of wavelength is wave number. Next one, amplitude. It is defined as the height of the crest or depth of the trough of a wave. It is denoted by the symbol A. We can say, suppose if it is a wave, the height of the crest or depth of the trough is taken as the amplitude of this wave. It determines the intensity of the radiation. Next property, velocity of electromagnetic radiations. It is defined as the distance covered in 1 second by the wave. It is denoted by the letter C. All the electromagnetic radiations travel with the same velocity. That is, just like the light radiation, they travel with 3 into 10 to the power of 10 centimeters per second velocity. So C is equal to 3 into 10 to the power of 10 centimeters per second. This also can be written as 3 into 10 to the power of 8 meters per second also. Next property, time period. The time taken by the wave for one complete cycle or complete oscillation or even complete vibration is called as time period. It is denoted by the letter T. Its units are seconds per cycle. The arrangement of various types of electromagnetic radiations in the order of their increasing or decreasing wavelengths or frequencies is known as the electromagnetic spectrum. Means if you arrange all the different kinds of electromagnetic radiations in the increasing or decreasing order of their either wavelengths or frequencies, that we call as electromagnetic spectrum. Here we can see all the electromagnetic radiations are arranged in the increasing order of their frequencies or decreasing order of their wavelengths. So this we can say as electromagnetic spectrum. Thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates.